Hey class, all right, so as promised, this last example is going to be recorded so that you guys can refer back to it. Okay, so the one thing that I wasn't able to do was make sure that there was an arrow on this graph. There should be, so that should have originally been there. Okay, let's go through these problems. Let's start talking about domain. Now, this domain is going to be a little bit different because there is a break in the domain. And what I mean by that is that there is nothing in between these two jumps right here. No part of the function exists. If I draw a line at x equals -4, it does not intersect with the function anywhere, which means there's a break in the domain. Okay, so let's write it out. Well, the left arrow for a domain, even though it's pointing up towards positive infinity on the y's, the left arrow is actually going to negative infinity on the x's. So the domain does start on the left at negative infinity, and that's because there is a left arrow. Notice there's no right arrow. So since there's no right arrow, this will not go to positive infinity, okay? Now, the domain keeps going from negative infinity, and then it pauses. It stops here because after there, which is the x value -5, so it goes from negative infinity to -5 with a parenthesis because this is an open circle. Then there's a break. There's no y values. There's nothing occurring in between -5 and when it picks back up again here, which is at -3, okay? So there is nothing in between those. There is no graph in between -5 and -3. So we pick it up back again at -3, and then we go until when? Well, at -3, we keep going, and then, ooh, it pauses again. It pauses here at 2, and then it's really hard to see, but there is nothing in between 2 and 3. There is nothing in between 2 and 3. So there's another break in the domain. So we go from -3 to 2, and that 2 gets a bracket because it is an open circle. Okay, but then it picks back up. It picks back up at 3. Here at 3, and then it goes until 7. So it picks back up at +3, and it goes until 7. I'm sorry, that 7 should have a bracket. Whew, so these are definitely challenging, okay? You really need to think about, is there a break? Is there a jump from x value to x value? So just to reiterate, there was a break in the domain here, and there was also a tiny little break in the domain in between 2, let's make that even smaller, in between 2 and 3. There was a break. Where this left off at 2, it started again at 3. Now that's different than this because for these, notice that this graph, it left off at x equals 0, but then look, it started again at x equals 0. So I didn't need to break up the domain. And then this stops at x equals 4, but then it starts again at x equals 4. Whereas this one stopped at -5, and then it didn't start again until -3, which means I needed to do a break in my domain, okay? So that is the domain. There's 3 chunks to it. Now, the range is bottom to top. So where's the bottom? Well, the bottom's here at -3. And that's a bracket. Now, let's see, is there a break? Well, no, let's see. The first break, I guess, would be here, but there isn't nothing, right? There was nothing in between those two jumps, but there isn't nothing here. There's a part of the function no matter where I draw. There's always a part of the function no matter where I draw a horizontal line. Okay, so that means that this is going to keep going, and since it's going up forever, we're going from -3 to infinity. Okay, so when we're figuring out domain, you could draw a bunch of vertical lines. There's nothing here. Okay, but there was nothing in between the 2 and the 3. but there was something everywhere else. Whereas range, you can draw a bunch of horizontal lines. Is there a function that's intersecting with one of those horizontal lines at all points? All right, so that's the way you want to think of domain and range. Now, increasing, decreasing, constant. So increasing is where is the function rising from the left to the right. So I'm gonna highlight this with like a turquoise color. We are increasing here from the left to the right, and I think that's it. That's the only chunk. Whereas we're decreasing, even though this arrow is pointing up, from the left it's actually coming down. We're decreasing, and then we're decreasing again here. And then the last one is constant. It's horizontal. So the purple areas are where we are decreasing, and we want to use our x values and interval notation. So left arrow is negative infinity. We are decreasing from negative infinity up until here, which is -5. And there's a second chunk. We are also decreasing from x equals -3 to x equals 0. We could do a parenthesis. Again, it doesn't matter for parentheses and brackets. I'm just going to do open circles, get parentheses, closed circles, get brackets, just to stay consistent. Now we are increasing from 0 to 2 on the x's. Increasing from 0 to 2. And we were constant, the pink, from x equals 3 to x equals 7. Again, I will stay consistent. Open circles get parentheses, closed circles get brackets. So there's my increasing, decreasing, and constant. All right, where are we discontinuous? Where are we discontinuous? At what x values? All right, I'm going to erase what I have on the graph because now we're talking about something else, discontinuities. So there's different ways you can say this, but I would say we are discontinuous here, here, and here and here. I would say you could probably say, because there's a bunch of different jumps. Okay, so we are discontinuous at the following x values: -5, -3, and then there's also a jump at 2 and 3. -5, -3, 2, and 3. Now, there's different ways you could say that. You could say that we were not continuous from -5 to -3 and not continuous from 2 to 3. You could make those intervals, but I'm okay if you just say the x values, okay? And then finally, we are evaluating. So last but not least, f of 0. X is 0 when y is -3. F of 2 is the filled in circle at 1, y was 1, and f of 3 is here, and guess what? That's a hole. That doesn't exist. So since that point doesn't exist, you cannot say the answer is -1. Since it's a hole and there's no other filled in circle at that point, there is no f of 3. There's a hole there. All right, so that's a lot, and it takes a while to really think about these. The key is going to be practice. So practice, practice, practice. You've got this.